Hello children, a warm welcome to you all. In the previous session, we learned about the heating effects of electric current and electricity in our homes. Now in this session, we will learn about the important topic of magnetic effects of electric current from the lesson Electric Current and its Effect, Class 7th Science. Learning outcomes. At the end of this session, you will be able to understand about magnetic effect of electric current, electromagnet, electric bell. Keywords: electric current. Flow of electric charge is called electric current. Magnet, compass, electromagnet, a soft iron core made into a magnet by the passage of electric current through a coil surrounding it. Electric bell. Before starting the session, let us look at the concept map of this session. To understand the magnetic effect of electric current, let us do an activity. Take the cardboard tray from inside a matchbox. Wrap an electric wire a few times around the cardboard tray. Place a small compass needle inside it. Now connect the free ends of this wire to an electric cell through a switch. Note the direction in which the compass needle is pointing. Bring a bar magnet near the compass needle. We observe that the compass needle gets deflected. Now, while observing the compass needle, move the switch to the on position. We observe that the compass needles gets deflected. Move the switch back to the off position. The compass needle comes back to its initial position. We know that the needle of a compass is a tiny magnet which points in the north to south direction. When we bring a magnet close to it, the needle gets deflected. We have also seen that the compass needles gets deflected when the current flows in a nearby wire. Hans Christian Ørsted was the first person to notice the compass needle deflection every time the current was passed through the wire. So, when an electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. To understand the concept of electromagnets, let's do an activity. Take around 75 centimeter long piece of insulated flexible wire and an iron nail, say about 6 to 10 centimeter long. Bind the wire tightly around the nail in the form of a coil. Connect the free ends of the wire to the terminals of a cell through a switch. Place some pins on or near the end of the nail. Now switch on the current. We see that the pins are attached to the tip of the nail. Switch off the current. We see that the pins fall off from the tip of the nail. The coil in the activity behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. The electromagnets can be made very strong and can lift very heavy loads. The electromagnets are also used to separate magnetic material from the junk. Doctors use tiny electromagnets to take out small pieces of magnetic material that have accidentally fallen in the eye. Many toys also have electromagnets inside them. We are quite familiar with an electric bell. It has an electromagnet in it. Let us see how it works. The circuit of an electric bell is shown on the screen. It consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. The electromagnet now pulls the iron strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. The coil is no longer an electromagnet. It no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated in quick succession. The hammer strikes the gong every time the circuit is completed. This is how the bell rings. Points to remember. When electric current flows through a wire, it behaves like a magnet. Hans Christian Ørsted was the first person to notice the compass needle deflection every time the current was passed through the wire. A current carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. The electric bell has electromagnets in it. Thank you for watching.